Team Sadlich-Spiegel. This is a presentation on our Zoo Care robots. Our presenters are Ryan Sadler, Chris Ulick, Tyler Stewart, and myself, Chris Ziegel. Our problem area that we have is the zoo staff are overworked and burnt out from a series of tasks they are assigned to do. And our customers we are targeting are the zoo management and the zoo staff who will be helped by the system. Our proposed robots contributed with the Nutrimax rover, which is a feeding system that encourages foraging behavior, bio-waste remover, which cleans the habitat, the tracker bot, which tracks the location and behavior of the animals, and the environmental welfare bot, which checks the temperature and humidity. We have the tracker bot, whose purpose is to track the inventory of animals and maintain an accurate head count. It is designed to work as part of a network of tracker bots that work together with the inputs from the environmental welfare bot. The multiple articulating joints will allow the tracker bot to look in all of the corners and giving a 360-degree view of every enclosure so it can track every animal where they are and where they are not supposed to be. If an animal finds itself not where it is supposed to be, the tracker bot can alert the zoo staff by use of its spotlight or its laser pointer, directing the attention of the zoo staff to where the missing animal can be located so that it can be collected and returned to its proper location.
This is the feeding robot. It is basically designed. The food goes inside it and is funneled to the food dispenser that drops through the hole. That is controlled through the servo motor. There's two DC motors that control the front wheels, and there's an ultrasonic sensor that makes sure it doesn't crash into anything. And then there is a servo motor that controls the food dispenser right here. And then the algorithm works by reading its distance sensors, and then it gets information from the climate and tracking robot, and then it dispenses the food at the set locations. And then the location is sent to the bio-waste remover, just in case if the uneaten food is has to be cleaned up later. And then it loops until it's empty, and when it's empty, then it goes to the charging dock and alerts the staff to refill the bin.
For the bio-waste remover bot, we went with a more robust, tractor-like design. So it has off-roading style wheels and a forward bucket with which it can pick up feces, much like a bulldozer would. And then it has an onboard waste bin for the operators to empty out. For it to work, you have 4 DC motors that provide power to the wheels, and it is steered by these 2 microservers for the front wheels, and the bucket is operated by these 2 microservers that pick it up and allow it to put the feces into the waste bin at the top of the robot.
The environmental welfare bot will be wall-mounted. Its functions include temperature, sound, and lighting sensors with an alert light for visual communication and an internal signal communicator. It will always be actively sensing each enclosure. It will use its communicators to signal staff for enclosure abnormalities. For example, if an enclosure is set to a maximum temperature of 95 degrees and a minimum temperature of 50 degrees, and the bot detects temperatures out of this range, it will communicate the abnormality to the staff. From there, the staff will physically take over to fix the abnormalities.
So the way the system works is 2 of the robots are continually active, the environmental welfare bot and the tracker bot. Both of them have to stay on and within the animal enclosure to be able to detect and alert anomalies to the zookeepers. The Nutrimax rover and the waste removal bot do need operator inputs, whereas for the Nutrimax, it'll be the operator fills it with food, turns it on, and sends it out to feed the animals, and then when it comes back, they'll turn it off. For the waste removal bot, they'll turn it on, it'll go out, pick up the feces, and then return, and the operator will turn it off and empty out the feces into whatever waste removal program they have. The programs that we benchmarked this off of were the feed pods and the Toronto Zoo robots. And the main thing that we noticed is they only solve single tasks. They don't work as a system, which is what our advantage is. Our system communicates as a team, which will result in less errors and less workload for the zookeepers.
In conclusion, all the bots we've created will work in tandem with one another and the staff to keep each enclosure and its animals safe and well taken care of.